All right, welcome back again. So we are looking at PCA now and shape variability results. Don't forget, last time we computed our PCA principal components in how we also repeated the same thing in past. Don't forget that. And we got some values. Okay, you have to keep this. You have to keep them because you need them later for the analysis. You could also further computed further compute the PCA for individual disease. Also, that could be additional information for your discussion. Okay, you can do that after you have done the general computation of the PCA for both disease combined together. Then you can also do individual computation of each disease PCA. All right, so that you can know what you get when the disease is divided and computed separately. You can know what are the how many PCA do you have, what are the variability of the PCA. All right, so that is good. So looking at this now, you understand that we have a figure A, B, C as this how it's supposed to be presented in manuscript or thesis. Make it very simple, so you don't need to be placing them one by one. You can arrange them in this format. So this is a group plot now. Now you can uh, make it a figure 3, for example. Just example, figure 3 can be figure 2, figure 4, figure 5, depends. I'm assuming that you have other two figures before this, and we call it PCA visualization. So A is called distribution of specimen in morphospace along PC1 versus PC2. That is this one, okay? Distribution of the morphoJ. So we have fragile S and William. Fragile is red, and William B is a blue color. So PC1, PC2, all right? That's the distribution of the specimen in morphospace. You can see how they are distributed in morphospace. So we're not trying to discriminate here, okay, or try to cluster them. Okay, we just want to show them how they are distributed in morphospace. All right. Likewise, we have lollipop graphs. These are lollipop graphs. Okay, associated with the first PC of the shape variability for fragile X. This is for this one, and the lollipop graph associated with the first PC of shape variability for the Williams Buren. Okay, so don't forget our PC1. We got what at 34.80 then. Remember, at PC2 we got was 24.98. During our GPA, after we computed our GPA general postcode analysis, then before we did our PC computation. So that to put this one in your report now. We can also discuss some things under this briefly by simply saying for all computed PCs, PC1 and PC2 explains more than half of the total variation. Yes, because when you add 34 together with plus 24, already more than half. Okay, good. Which indicates that shape variation is not concentrated in a single dimension of the shape space. No, I explained last time that sometimes it can concentrate on a single dimension, like a PC1 can have almost 80% or 90%. All right, these are in percentage. Okay, forgive me, I did not put percentage there. It would be 34.88% and 24.98%. Please add to your own their percentages, please. All right, so we understand that now the PCA of total sample yielded 60%. Is it 60% now? Not up to, let's say, almost 60%. Okay, with few zero variability. The two PCs accounted for almost 60% now, okay, of the shape ratio, where PC1 is 34.88% and PC2 is 24.98%. Right? The distribution of specimens in morphospace along PC1 to PC2 is shown in the figure 3A. All right, that is how to point to it. You have to point to it. Okay, then to visualize the facial variation in each group, lollipop graph of the first principal component was plotted, which is we have seen in B. All right, you can put that in B using the mean shape of the source configuration. So okay, that's what we use. This shows the shift of landmarks positions with a straight lines. All right, the length and the direction of the line indicate the movement of the respective landmark in the mean shape. Okay, figure 3b and 3c. Okay, in the visualization of the specimens, the number of landmarks is shown in red. Okay, number of landmarks is shown in red. Okay, and the mean configuration is shown in light blue. That's the one is in the blue, like light blue there. All right. Each of those circles is the average position of the landmarks that are used, and the sticks tell us which way things change along the principal components. Okay, those sticks you are seeing, that is what it does. And if a specimen has a high WAP score, then the shape is further down the stick. All right. Now, in a fragile S, the nose and the upper lip protruded leftward. All right. The upper region of the left cheek projected outward. Looking at the fragile S now, while from the chin to the upper right cheek projected inward, and the upper lip protruded leftward and downward. Okay, looking at this shape now for fragile S. But meanwhile, in Williams, Buren, the nose protruded rightward and slightly upward. As you can see, the upper region of the right cheek projected outward, while from the chin to the upper left cheek projected inward, and the upper lip protruded rightward and upward. These are just explanation of this particular diagram, which you can just provide, and you can check that article online that I showed us for more clarification and understanding about this. So these are the basic things you need to understand. So this one can be put in your this thing, and then you can do more analysis on it. Then you can now go online, try to check other clinical reports on this disease, and add more information from there to balance your discussions. I think we have covered enough now, and in the next time we'll be plan to round up this particular course, and I think we have done a good job for now. So I wish you can still do more. There are other things that you can dive into under this course, but at this for limited time and space. But let's leave for now. This should be enough for you to kickstart your research research work, and you can build on it and build on it. Any question you want to ask or any comment, you can just post to me. Let me know, and I'll give advice as deemed fit. Thank you so much for availing yourself to be partaker of this particular knowledge, and I thank you so much that we will see you again in another course. Thank you so much.